Alright guys, so before we get started, or finishing up the lesson yesterday, that we got interrupted with the pressure washer, because that's what they were actually doing, are there any questions? Well, hopefully that won't show up again. But the last thing we're talking about today with this section is circles. So we talked about that, recognizing as probably, well, for a circle is defined as a point and all the points, or pretty much all the points that are equidistant from the center. The circle consists, shown here, a point xy lies on the circle if and only if its distance from the center hk is r, just the radius. All the points that are equidistant from the center. And by squaring each side, we get the standard form of a circle, x minus h squared plus y minus k squared equals r squared, where h comma k is the center. And if the center is 0, 0, we really just have x squared plus y squared is equal to r squared. So the point 3, 4 lies on a circle whose center is at negative 1, 2, as shown in the figure. Write the standard form of the equation for this circle here. So this is our standard form of a circle, the just general equation, and we want to write it in. We want to fill the information in. Now what we know is we do know what the center is. The center is negative 1, 2. So we can fill that information in. So we can say x minus negative 1 squared plus y minus 2 squared. We just fill the x value in next to x and the y value of the center in with the y. Pretty straightforward so far. Now the only other thing we need is the radius, which is just going to be this distance here. So we can use the distance formula, which is our x2 minus x1 squared plus y2 minus y1 squared. We can use the distance formula to find this length and go from there. So our two x values are 3 minus negative 1 squared, and our two y values are 4 minus 2. Now the order in which we put the x's inside the parentheses of the y's really doesn't matter. I always put them in a way that makes it easier to work with. Because I put the negative 1 second, because 3 minus negative 1 is the same as 3 plus 1. I put the 2 second, because 4 minus 2, that's easier to work with, instead of 2 minus 4. Now at this point here, you could have typed the whole thing in, and especially if we're dealing with a radical, I would type it into the 30xs, xs, not x2s, calculator, because it will simplify radicals nicely if they will simplify. Here we have 3 plus 1 is 4, 4 squared is 16, plus 4 minus 2 is 2, 2 squared is 4, and 16 plus 4 is 20. Now if we did plug this in, it would tell us that the distance is going to be 2 square root of 5. But at this point here, I'm just going to leave it as is, because it's not specifically asking us what's the radius, the length of the radius. It's just wanting us to find the equation, yes? And what are we going to have to do with this radius length to plug it back in? We have to square it, yes? Well, I could ask, what is 2 square root of 5 squared? And that's a little bit harder to see, because we have to square the 2. 2 squared is 4. Square the square root of 5 and go from there. So it might not be as easy to see what this value is. Let's erase that. What's the square root of 20 squared? 20, yes? So the value that goes here is 20. Almost finished. We actually have to turn that into a plus, but that's it. Questions on this here? And if you were wondering, 2 squared of 5 squared is 20 still. Any questions on what we did here? Found the square root of 20, plugged everything back in, and got our standard form. Any questions on any of this here? Okay. So this here is the assignment. I'm going to grab the book. So 15 through 20. So 15 through 20, we didn't specifically talk too much about this, but it's determine which quadrant XY can be located. So number 15 is told to us is X is greater than 0 and Y is greater than, less than 0. And what we're talking about with all of these here, 15 through 20, is which of the 4 quadrants? It's asking which of the 4 quadrants, you're welcome, it's going to lie in. So with any Cartesian coordinate, there's only 4. 1, 2, 3, 4. And if we're saying X is greater than 0 and Y is less than 0, so where is X positive and Y negative? Well, X is positive this way, yes? And Y would be negative. So the only one that contains both of those is? So that'd be your answer. So you're just figuring out where are the values located given the restrictions. So if that's somewhat kind of, you need to visually see it, draw out a coordinate plane and figure out where do these restrictions take place? Where do these fall? Does that kind of make sense? If you do have questions, please let me know. See here. 23 through 26. Find the distance between the 2 points using distance formula. You can, if you want to write the whole thing out step by step, go for it. If you just want to write it down to start with, go for it. If you feel comfortable with just plugging the whole thing in the calculator and finding the answer, that works too. 27 and 28. Find the length of each side of the right triangle and show that these triangles satisfy the Pythagorean theorem. Find the length and then plug them into the Pythagorean theorem. You don't have to do the step-by-step out, at least show one, the side length's plugged in, and then the following is that they actually equal the same amount. Or this side's 3, this side's 4, this side's 5. So 3 squared plus 4 squared equals 5 squared, 25 is equal to 25. You don't need anything more than that. 33 through 35. You don't have to plot the points, but find the distance between the points and find the midpoint. So 33 through 35, just distance and midpoint. 41 through 44. Determine whether each point lies on the graph of the equation. It only lies on the graph if it makes the statement true. So you plug in the x and y values and their corresponding parts. Do we get a true statement? If we do, then yes, they do lie on the graph. If they don't give us a true statement, then they don't. And the last set, 83 through 85. Write the standard form of the equation of the circle, given the characteristics. So 83, 84 give us the center and radius. 85 is the only one that doesn't, and it gives us the center and a solution point. A solution point is just a point on the circle, so like the one we did. And that's it.